Okay, now on with our M4 thread. I'm actually going to use a plug tap because I broke the other two, believe it or not. I haven't broke taps for years, and then you break two in a week. It's unbelievable. It's always a good idea to use a countersink bit before you start the tapping motion. We'll run a drill. Use this in a hand drill. It stops the thread being erased on that surface, and it's easier to do it before. You do it before, it looks all neat and tidy. If you do it afterwards, the countersink moves off to one side. Not so good. Well, I said I'd do it with a hand drill. Just as well do it in the mill, simply because we can. Okay. There you go. I'm happy with that. Meanwhile, back here, we're ready to go ahead with M4. I'll use cutting fluid. It's got to be precisely lined up because it's a plug what I call a plug tap, or a bottoming tap. So it's harder to actually get this one. It's harder to get him in and to get him lined up, but I'll show you that it's quite possible. Even this is the most difficult, possibly the most difficult one of all. Happy with that. You got in line and in line at 90 degrees apart. Off we go. Remove the yes word. Okay. Okay. That seems good. You feel it just at the bottom. You feel it. Okay, move on to the next one. Right, we'll move on to number 2. Find up to me, that's pretty good. I'd say that's lined up. These parallel flutes, you really feel like you mustn't let the support fill up so it traps the tap, because next thing, snap. Okay. Right, you can go into the bottom of something. Yeah, that's about it. Yeah. Feel resistance when you push the bottom. Don't be over-racing underneath. It's easy to press out the originals. It's not good. The last one's there. There it is. Yeah, straight away, straight away. That's it. There you go, that's it. How many do you now? Well, I think two things really. We could use this countersunk screw, but it would have to be I don't know if a true countersink for a 4mm head will actually clear that or not. I'm not sure, but we'll use whatever we end up using is going to be threaded to the head itself. So we'll just do a tight fit on the threads, which is, generally speaking, well, look at that, 3.77 is normally about 3.85. I'll go for what we got near, close to 3.85. Okay, we're ready to start tapping the holes in this adapter. We possibly could have done it in the lathe, but if it's held in the lathe like that, we can't use a wrench because the chuck would be in the way. We can actually we could have held it out of the lathe. Really makes no difference. But I'm quite happy using taps in my hand. You know, I don't have to use lining up methods. When I'm using grub screws, I normally always use cutting fluid. The reason is it tends to do a closer tolerance thread than if you was cutting it dry, so yeah, line up the tap of the hole. Going good. Spot on to me. We'll run that through. See it come through. Straight. Make sure you don't drop it because there's a hard time it's not in the tap. So we clean the threads out. Also, you get a build up of the threads. That is just going to do is chew its way through the hole. And the thread is created and it's destroying at the same time. So if we can, line it up. Good. We're going to end up this side just on the in the core. We're just going to make it as possible onto the shaft. We have to clean those out carefully. There we go. Sometimes clean out the salt and blade. Carefully use the files and you can do. Generally don't pounce the outside on the needles with the thread as possible. That's something you can sure now. I'm going to do a trial assembly, mainly to find out if we got to actually lengthen this frame or shorten it or whatever. I've bolted on this the new adapter onto the coupling, and I've slid the adapter onto the stepper shaft. I've got two grub screws at 90 degrees here. Quite a bit of thread still exposed. I'm not absolutely I don't know. It might be adequate, it might not be. If it's not, it means making another adapter up, which is not a problem, because this was intended as a trial adapter even in the first place. So there's no problem. So, but that is slid down to the end of the flats on the shaft, the motor shaft. So it can't go in any further unless I miss the flats with the grub screws. So really speaking, that's the maximum in. It can come out slightly, but I don't really want it to come out much, because I want to make use of the full diameter back here. It's a nice tight fit. I haven't tightened these up. These aren't tight. They're just pinched down. Pinch down. So there's no problem, but I will pinch them just because I don't want them to move at the moment while I'm actually fitting this. So we go over to the lathe now. I've not very good lighting here, but I'll see what I can do. We got the shaft sticking out, and where the grub screws actually go in is a small pocket, a drilled pocket. So I really can only attach this at one point and make sure that I've got a decent. It is actually going to function without slipping. So there's one there. There's a pocket there and a pocket there, and these aren't interestingly, they're not at 90 degrees apart. But anyway. We'll slide that in and hopefully we'll pick up that. I've got the grub screw in here. I'm hoping to pick up some. I'm going to pick up. Okay. Somewhere there. Okay, I'll take that. He's going in. Definitely. I'll let you finish that. Remember, I need to support the shaft motor. Actually, that ain't bad. Yeah, that'll do. I want to need to measure now the distance between this plate here and the motor flange. So I'm going to use the pen here. I don't know if you can see that, but that is 97. It's 97 millimeters from the end of the ruler. Okay, that's about 97. 90, just over 97. And over here we got 95 and a half, so he's not quite true. Try again. 96. 96. And over here we got 90. Ooh, 6.5. I'll go with 95. I think 95 will, then the grub screw won't be at the extreme end and being trapped at the extreme end of the flat then. So definitely go from 90, and that's not 95 millimeters, that's 95 from the end of the ruler. Let's see what we got here. Well, virtually exactly 100. Yeah, that's inches. We got 100 and 100.5 mil. Yeah, it was meant to be 100. And we want 95, so it's, we need to take off, well, exactly, we'll take off exactly 5 mil off the 4 of the extensions. We need to strip this apart now and take 5 mil off. Right, the pillars are held on by countersunk screws. I'm just hoping that they appear to be metric. The metric key is fit in, so Christ, that was a bit tight. This obviously hasn't touched something, mate. The tube would be nice. Right, the tube in. That's it. Okay, it's off. I'll try to keep some orientation between the slot there. That is top on the inner plate. This top, so. I mean, there are 2 lines there. Oh, and there. Oh, that's what it's in the okay, I'll take those out. I know now that those top are 2 tops, right? Okay. I'm going to change the cutting tool. I'm going to break the this. It's the newest cutting tool I have in my hand. There we go. Oh, there. Our centering the rotating, you can see. Here, all that centering against the rotating centre here. You can actually see that. This is the other side, tool reverse. I'll say this one on there. Yep. Right, so that's our cutting tool. I'll take the opportunity to wire brush these, get rid of any surface rust. And all we need to do now is take off 5 millimeters, which is well 195 thou. So I'll round it off and go for the 200 thou. So I'll set the compound slide to 0. Touch the face. Look at the cross slide. We're ready to go. I need to take off. I'll use a fairly high speed here, I think. There we go. Yeah, 200 thou. Just do it. It wasn't cross side, wasn't actually locked, it's just a pinch screw, so